Hello STEM students, I'm Mr. Moises S. Flores, your pre-calculus teacher. Today, we're going to discuss all about the very first lesson on pre-calculus, which is Introduction to CONIC sections. Okay, we have here our learning competency, which states that illustrates the different types of conic sections, namely circle, parabola, ellipse, hyperbola, and degenerate cases. We have also here our learning objectives. The first one, we're going to illustrate the different conic sections. In here, we're going to sustain learning systematically by providing graphs, figures, and videos. The second one, distinguish the different conic sections. We are going to give definitions, illustrations, and comparisons. And of course, the third one, to show appreciation to the concept about conic sections. In here, of course, we're going to give real-life examples which could be found around us. Okay? So let us have now our definition of conic sections. We have conic sections if a plane intersects a double right circular cones. The intersection is a two-dimensional curve of different types. Did you know that these curves now are called conic sections, and in some other textbooks, it is called conics for short. Now, what are these different types of conics? The first one we have here, circles, ellipses, parabolas, and of course, hyperbolas. Let's start with the first conic sections. And we have here, yes, you're right, circle. The question is, how do circle form? Circle was formed if the plane that intersects the cone is perpendicular to the axis of symmetry of the cone, as what the arrow diagram shows us. Okay, when the plane is horizontal, there you form a cone, or from that horizontal of the plane figure, there form a circle. Okay, let's watch this movie clip. Okay, take a look and observe on this movie clip or clip. Okay, as the plane moves horizontally with the cone, the graph is either what? It becomes smaller or bigger. And notice also that when the plane reaches the apex of the cone, it forms a point that is now called your degenerate case of a circle. So again, the degenerate case of a circle is simply a point. Okay, let's further define what is circle. Okay, when it's a circle, it is set of all points equidistant to a fixed point, as you notice on our two diagrams there. Okay, the fixed point now is called your center of the circle, wherein the center is usually the process when naming a circle. And then, of course, the equal distances from the different points along the circle to the center is called now your radius. Okay, take a look on our diagrams there. Okay, especially on how to construct a circle. Okay, let's move. Now, let's take some examples of circles. Okay, so can you name them around you? We have some examples here. We have cookies, dartboard, compact disc, and a wall clock. Okay, these are all real-life examples of circles. And we have lots of examples around us, be it at home, in your room right now, and of course in our environment. Okay, let's proceed with the next property, and that is all about the general equation of a circle. Okay, for the general equation of a circle, both your variable x and y appears on the second degree, and the numerical coefficients are the same. Take a look on the formula. We have your ax squared plus ay squared plus cx plus dy plus e equals 0. As an example here, we have 18x squared plus 18y squared minus 24x plus 48y minus 5 equals 0. Okay, now how would we graph this one? We have here the graph, of course, centered at HK. Don't worry, we will be discussing further on our succeeding lessons on how to graph circles. Okay, so again, The first conics we have discussed is all about circle. Let's proceed with the next type of conics. Okay, with these examples or these figures, what do they have in common? Yes, they have all said to be in parabolic shapes. When you throw a ball, the trajectory it takes is a parabola. We have here a satellite dish, a tunnel, and a fountain. They are all parabolic in shape. These are all real-life examples of parabolas. Now, the question is, how do parabolas form? Okay, parabolas form when a plane that intersects the cone is parallel to an element of the cone. Or simply, with that arrow diagram, when the plane intersects only one cone to form an unbounded curve. Okay, so let's watch again a clip on how to form a what you call a parabola. Okay, so a parabola was created when the angle of the plane and the cone are said to be equal. Observe now the plane as it moves on the cone. Okay, there you have. Now, you notice that the parabola degenerates a line, okay, once it reaches now to its generator. Okay, so again, for a parabola, it generates now a straight line. Okay, so there you have how parabolas form by moving a plane on the cone. Okay, let's define further what is a parabola. Parabola is said to be set of all points such that its distances from the fixed point and from the fixed line are the same. So take a look on these two figures we have. Okay, so the fixed point now is called your focus of the parabola, which denotes now the F on that figure moving. On the other hand, the fixed line is called your directrix, the one on K or H on that figure. Okay, there are some terms also. We have your axis of symmetry, we have vertex, and latus rectum. Okay, don't worry about these terms because this would be discussed further on our succeeding lessons. Let's proceed now to the last property of the parabola, which is on its equation. Okay, exactly one of the variable x or y appears on the second degree. So if we compare with circle, both x and y are said to be in the second degree. But for parabola, only one variable is said to be in the second degree. Okay, so we have here x squared plus cx plus dy plus e equals 0. Okay, take note that on the second degree is your variable x, therefore it opens upward or downward. On the other hand, we have here another formula, by squared plus cx plus dy plus e equals 0. This time, your variable y is on the second degree, so therefore it opens either to the right or to the left. We have here an example, 3x squared minus 12x plus 2y plus 26 equals 0. Could you guess where does this parabola opens? Okay, you're right. The parabola opens downward because your variable x is on the second degree. Okay, again, don't worry because on our succeeding lessons, we will discuss how to graph a parabola. So there you have the circle and the parabola. Let's proceed with the third type of conics. Okay, with this third type of conics, consider this figure. Okay, what do you observe? The orbit taken by the Earth around the Sun is an ellipse. Okay, and what else? The football and the earring are said to be elliptical in shapes. These are all real-life examples of ellipses. And we have still lots of examples around us. Okay? Now, the question is, how do these ellipses or ellipse form? Okay? Take a look on this. When we say ellipse, ellipse was formed when the plane that intersects the cone is neither parallel nor perpendicular to the axis of symmetry of the cone and cut through two sides. Take a look on that arrow. Okay? When the tilted plane intersects only one cone to form a bounded curve. If we compare a while ago with the parabola, it is said to be unbounded, but this time it is bounded curve. Okay, let's watch this again for another clip. How do ellipses form? Okay. An ellipse is created when a cone is cut less than 90 degrees but greater than the angle of the plane. Observe as the plane moves on the cone. So just like circle, once the plane reaches the apex of the cone, it degenerates a point. So again, circle and ellipse, it degenerates mere point. Okay. So, let's formally define what is an ellipse. It says here, set of all points whose distances from the two foci add up to a certain constant. Okay? This time we have two focus or foci, two vertices in our major axis, and two co-vertices at the ends of minor axis. Okay? These terms are again to be furtherly discussed on our succeeding lessons. Okay? So the other diagram shows us how to graph a or an ellipse. Okay? Now let's move to the last property, and that is all about the general equation of an ellipse. Okay. So it says here, just like circle, both your variable x and y appears on the second degree. Okay? And of course, this time, the numerical coefficients are said to be different. Okay? But this time, they have the same signs. Just like circle, if you compare with circle, they have the same numerical coefficient, the same positive, and of course, both x and y are on the second degree. But for an ellipse, okay, both x and y are on the second degree, and their numerical coefficients now are different. Okay, that's why our formula is ax squared plus by squared plus cx plus dy plus e equals 0. Let's take an example. 2x squared plus 5y squared plus 8x minus 10y minus 7 equals 0. You notice there, okay, both x and y are on the second degree, and of course, your numerical coefficients are not equal. Okay, how do we graph that one? There you have the graph. It is said to be horizontal major axis. Okay, again, okay, we would be discussing the ways or steps in graphing an ellipse on our succeeding lessons. Okay, so there you have the first three. We have the circle, the parabola, and ellipse. Let's proceed now with the last type of our conics, and that is, of course, your hyperbola. How do hyperbola form? Okay, the plane that intersects the cone is parallel to the axis of symmetry of the cone. Take a look on this arrow, or okay, you notice there that when the plane, not necessarily vertical, intersects both cones to form two unbounded curves. Okay, it's called now a branch of the hyperbola. Okay, let's watch this clip on how a hyperbola formed. Okay, just like other conics, observe how parabola or hyperbola was formed as the plane moves. In here, hyperbola, okay, degenerates two intersecting lines. A while ago in our parabola, it degenerates a line. But for hyperbola, it degenerates two intersecting lines. Okay, so there you have as the plane moves around the cone. Okay, there you have it. And let's furtherly define how is or what is a hyperbola. Hyperbola is said to be set of all points whose distances from the two foci differ by a certain constant. Okay, as it shows here on this diagram. Okay, if an ellipse contains two parabolas facing each other, we could easily note that hyperbola contains two parabolas facing opposite each other. Okay, the major axis or your transverse axis, usually the location of the foci and the vertex or vertices. On the other hand, the minor axis or the conjugate axis are usually the location of the minor axis. Okay, we have also here the term asymptote as you observed on our diagram, and of course this will be furtherly discussed on our succeeding lessons. Okay, now let's take these examples. Take a look on this. Okay, for our information, did you know that the properties of hyperbolas have been used in the design of a certain telescopes and navigation systems? Wow! So that's an application of hyperbola. And here are other real-life examples of hyperbolas. Okay, can you find hyperbola right now in your area? Okay, let's proceed now with the general equation of a hyperbola. So just like circle and ellipse, both x and y appears on the second degree. And this time, for an ellipse, they have a different numerical coefficient, and for hyperbola, different numerical coefficient. But this time for hyperbola, they have different signs. So that's the difference between hyperbola and an ellipse. Okay? So we have here the formula, ax squared minus by squared plus cx plus dy plus e equals 0. So again, for the general equation, both x and y is on the second degree, different numerical coefficients, and different signs. We have here an example, 5x squared minus 3y squared minus 20x minus 18y minus 22 equals 0. Okay? So there you have also the graph. It is said to be horizontal transverse axis. So again, the steps and process for graphing a hyperbola would be furtherly discussed on our succeeding lessons. Okay? So there you have our 4 types of conics. Okay? Let's sum it up or generalize. Okay. Let us generalize what we have discussed today. Okay, when you see circle, circle was formed when the plane is horizontal. On the other hand, ellipse was formed when the tilted plane intersects only one cone to form a bounded curve. And for a parabola, the plane intersects only one cone to form an unbounded curve. And of course, lastly, we have the hyperbola, was formed when the plane that necessarily vertical intersects both cones to form 2 unbounded curves. Okay? Aside from that, for the process of the formation of these conics, we have also to sum up with its equations. So do you still recall our identity or for the identification of your equation of the 4 conics? Take a look on the first equation. Okay, we have negative 3y squared plus 5x squared minus 20x minus 18y minus 22 equals 0. What type of equation is that? What conics? Okay, you're right. That is now a hyperbola. Because what? They have said to be different numerical coefficients and different signs with respect to your x and y on the second degree. How about number 2, the second equation? Okay, 3x squared minus 12x plus 2y plus 26 equals 0. Yes, you're right. It's an example of a parabola because only one variable is on the second degree, and that is with respect to x. How about the third equation? X squared plus 9y squared minus 12x minus 5y plus 25 equals 0. Okay, you're right again. It's an ellipse because both x and y is on the second degree and they have the same sign yet different numerical coefficients. And lastly, okay, take a look on that equation. It's an example of a circle. Yes, because both x and y is on the second degree, they have the same signs and the same numerical coefficients. Okay, so thank you. And of course, hoping you have learned something today in our discussion. Thank you for listening, and of course, take note. We have here handang isip, handa bukas. Tara na, ML na tayo. Okay? So, thank you guys. See you again on our succeeding lessons.